So I'm going to just talk a little bit about eclipses and the nodes, even though I'm sure most of you know this, but maybe you don't. Some of you might be beginners, because we just want to get a little bit of an idea, what the nodes and the eclipses do in order to understand a little bit about the cycles. So an eclipse, or in Sanskrit, it's called grahana, which is the act of seizing or holding. An eclipse is an occultation. And it's formed when the sun, or Surya, if you're used to Indian Sanskrit, the sun or the moon, or Chandra, is obstructed from view by a certain set of circumstances involving the earth, the sun, and the moon. Surya Grahana is the solar eclipse. Soma Grahana is the lunar eclipse. That's just the Sanskrit word for it. And the diagram on the following pages will show you, these are all from NASA. And if you do want to understand not just eclipses, but planetary cycles, if you want to see things live, like when they have the transit of Venus, it's quite a wonderful, wonderful website. It's just nasa.gov. And you can basically find anything you want on there related to the actual astronomy and physicality of things that we take for granted as astrologers, and sometimes don't even know about in terms of the astronomy. So a lunar eclipse is an eclipse of the moon, obviously, and it can only occur at the full moon when the sun is opposite to the moon and the earth comes between the sun and the moon, blocking the sun's rays from reaching all or part of the moon. These are things we all learn in grammar school, but frankly, a lot of us forget it, and the earth passes through some portion of the shadow, blocking some or all of the sun's rays from reaching the moon. And then this is important, that the outer or penumbral shadow over here, that is a zone, I'm going to put on my laser pointer. I think maybe that'll be better. So the outer or penumbral shadow is where the earth blocks part, but not all of the sun's rays from reaching the moon. So it results in a partial eclipse. In contrast, the inner shadow, or umbral shadow, is a region where the earth blocks all direct sunlight from reaching the moon, forming a total rather than a partial eclipse. And there are obviously different kinds of eclipses. There's the total, there's the partial, and that will also always, you might see it in the news, or if you go to earthandsky.com is always a good place to have in your bookmarks, because they will tell you all the time when there are certain phenomena in the sky, including things like Mercury retrograde. They might not be interpreting it astrologically, but they will, of course, always tell you when these things are occurring, and they will tell you what they mean. So I always like looking at that website as well. And then what happens, of course, is they will sometimes, when you have like the total eclipses, they'll tell you about the blood red moon and things like that. Not every total eclipse is like that, but sometimes that is, what happens, and it can be rather beautiful, but also why in ancient times, of course, people went a little crazy when it came to eclipses, because, suddenly the sky, at least with a solar eclipse, goes dark. With the lunar eclipse, it goes, it has this red aura. So eclipses are quite fascinating. The the Babylonians, who were really the first to observe, the things in the sky and write down what it meant for them in terms of what results they saw on Earth, whether it's fighting or meteorological things. They had lists and lists of eclipses. And those were the things they started to really time, because they actually could look at the sky, and they weren't so antiquated when it came to their mathematics. They were actually quite advanced. And that's how we even had those Saros and Metonic cycles that we are going to talk about. So the solar eclipse, though, the eclipse of the sun, can only occur obviously on the new moon or the sun-moon conjunction, when the moon then comes between the sun and the earth. So it blocks the light of the sun. And if the moon's shadow falls upon Earth's surface, then part or all of the sun's disk gets covered or eclipsed. When the moon's umbral, again, the umbral or inner shadow, strikes Earth, we see a total eclipse. If the moon's penumbral or outer shadow strikes Earth, we see a partial eclipse. it is those partial eclipses that are dangerous to look at. When you were a kid, I remember when we had, partial eclipses, and they would say, don't look at the sky because it's so bright. Those are not total eclipses, because the total eclipses block the sun. It's those partial eclipses, because the uneclipsed part of the sun is what is, actually very bright. So I'm sure all of us have experienced that, when we were kids and we were told not. I'm sorry, I'm a little bit, a little bit stuffed up today for some reason. So excuse me on that. Okay, so there are a pair of eclipses, the solar and the lunar, which occur within 2 weeks of each other. We just had two that were November 19th and December 4th. The next ones are going to be April 30th and May 16th. May 16th, when you see the exact time in Greenwich. May 15th, when you see it, the exact time in the States. So sometimes the lunar is first, followed by the solar 2 weeks later. Sometimes the solar is first, followed by the lunar 2 weeks later. Sometimes they come in a set of three, depending on, of course, where the angles and latitude are, where the sun and moon meet. So they are each 14 days apart. In 2018, for instance, we had a solar on July 13th, a lunar on the 27th, and a solar on the 11th. In 2020, there was a lunar on June 5th, a solar on June 21st, and a lunar on July 5th. But this coming year, we're like last year, we're only going to have four. So we're going to have the lunar on April 30th, the solar on May 16th, the solar on October 25th, and the lunar on November 8th. These are just the websites from nasa.gov. As I said, they really have just, fabulous, fabulous websites. And this is very, very verbatim, actually, from NASA, just giving you, in astronomical terms, which, I'm not going to spend a whole lot of time on, and just saying why we don't see eclipses during every new and full moon. And that doesn't happen because the moon's orbit around Earth is tilted. It's not exactly circular, anything like that. It's got that tilt, and it's about 5 degrees. Moon's orbit around the Earth tilted 5 degrees to the Earth's orbit around the sun. So that means the moon is actually spending most of the time either above or below the plane of the Earth's orbit. Again, there's a lot of, I didn't put one in, I apologize, but there is a lot of diagrams that you can actually see this online. And during the full moon, it will pass above or below Earth's shadows and miss them entirely most of the time. But twice a year, when you have those eclipses, as we just saw, the moon will pass through some portion of the Earth's shadows. That's when you have the eclipse. During the new moon, it's the same thing. The moon shadow misses the Earth as it passes above or below at the new moon. And then twice a year, the geometry lines up. So some part of the moon shadow falls again in that direction and falls on the Earth's surface. And that's really why you don't get those eclipses all the time, but that they actually are coming with a lot of regularity. So that's why you can predict eclipses years and years in advance, because you actually with regularity can see those cycles. And it is those cycles that are, really important in terms of astrology in general, and why we are able, I think, as astrologers, to go one step further than, let's say modern scientists who kind of poo-poo the idea that as above, so below. And that's what the ancient people did, whether they were Babylonians, Indians, Hellenistic, Persians. They all looked at the sky and understood that what was happening in the sky was reflected in Earth. And everything that was going on had its own story and its own cycle to it. And that's my particular interest, in astrology, in addition to a lot of other things. But I love cycles, and I love just studying cycles, and there are so many cycles.